Alright folks, let's talk angles. Now cross-section wise, this is what a piece of steel angle looks like, and you're probably familiar with this. You've seen these. These are your typical pieces of angle that you'll see on construction projects and that sort of thing. So if someone calls out and says, hey, I need a 4x4 angle, you can probably figure out what it is. The interesting thing about angles is they're used in a variety of different ways. For example, if we have a steel beam connected to a steel column, a lot of times what we'll use is we'll actually add a little shear plate right here, a little shear clip, which is a steel plate with a hole in it, and we'll put another one right here on this beam, a little break line for us, and we'll use a piece of angle to be a strut, or sometimes referred to as a kicker, to add a little extra strength to this particular connection. So the angle is used here. They're also used for a variety of things like laying down steel decking. So for example, if you were to look at how commercial buildings with concrete floors are made, especially on the second floor, what you'll typically find is the W-beam, used in some form or fashion, holding something up, or maybe it could be a W-beam, it could be open web steel joist, that kind of thing. But what they'll do is they'll take a piece of angle and put it at the end. And we're in kind of a cross-section view, by the way. And here's the steel decking. This is what it looks like in cross-section. And let's say there's some other beam on over there, and they'll pour the concrete into the space. Now what the angle does is the angle actually stops the concrete and creates a boundary for everything, so they can weld right here, and then they can weld the decking itself to the joist below and wherever else it is, pour the concrete in, and that's how you get your typical floor system. Another trick is what they'll do is they may lay a open web steel joist right here and set it on the big steel girder beam, and then here it goes out this way, and this is your open web steel joist, which is holding up the metal deck, which is holding up the concrete, which is holding up us on the floor, with the angle holding it all, kind of binding it together. So that's one of the tricks that we'll use with angles. So we can use them as struts, we can use them as kickers, obviously we can use them for all kinds of different things. Now in a set of plans, if we were to go back to that little detail I had right there, steel column, steel beam, kicker, member, shear clip right there, drill a bolt hole in the angle to match up. If we were to call this out on a set of plans, what you'll probably see is something like this. Now, I'll just draw this out and then I'm going to correct myself here in a second. A 4x4 by quarter. Now, actually, that's a little bit large. Likely, we'll say a 3x3 by quarter. Now, this dimension means one leg of the angle. This dimension means another leg of the angle. And, of course, that is the thickness of the angle. So, a 3x3 by quarter is from here to here is 3. From here to here is 3. And the overall thickness on both legs is a quarter. Makes sense. So they can be 3x3s, they can be 4x2s, they can be 5x4s. There's a lot of different variations of the legs. They don't necessarily have to be equal. But I do want to draw into the fact that I drew an L right here. Technically, it's really supposed to look a little bit more like this, implying angle. What most of the time on set of plans, you're going to see people start to use the L versus the actual angle alligator's mouth symbol. Either one means an angle. It's just that most of the designers aren't getting too picky about having that extra slant to it. So what they do is just use a simple L to type it out. Okay? So make no mistake, technically this is the more correct, but you're probably going to see just an L is the thing that they use most of the time. Alright? I say that to correct myself because I'm about to show it to you, and they're going to show it with that angle symbol versus an L. So here we go. Your typical call out is going to be the L or angle symbol, leg size, long leg, short leg, and web thickness. Of course, the whole thing itself is a web because there is no flange. Now, what's long leg, short leg? Obviously, the long leg is the longer one. That's usually the one that's called out first. So if it's a square angle, meaning that it's like a 2x2, then you're not going to have a big deal. They use the term heel for the joint or the connection between the two. Not too much going on. You can probably get the hang of it. However, what is also cool about angles is sometimes they can be used in tandem. So instead of just having one structural member, they can take angles and butt them up with each other, which by the way, this is also forms a T, so a T can replace this, but we can use like angles to reinforce or have double strength. So let's say there's a steel plate and we have an angle on each side for one of those kickers or struts that I showed, and we run a bolt between the two. So there is actually a whole set of properties associated with using two angles in these particular cases. So you may actually see double or DLB or something like that to represent the fact that you've got two angles running parallel with each other that are used together in conjunction with whatever they're doing. In fact, if you actually look at an open web steel joist, you know, it may look like this from the side. That was a bad version of it. Here we go. This is kind of how they look, and it may have this shape to it, but what they actually are using is they're using a steel bar to make this part, but they're usually using a double angle on the top and the bottom to form the top chord and the bottom chord of the truss system. Okay, so it's kind of actually what they're doing right here, is except the bar goes all the way up and this part wouldn't be down here. Again, you can always internet search this kind of thing, do a picture search to get a better feel for what I'm talking about, but these are some of the basics. Anyway, angle, there's its call out, used for a lot of different things in fabrication. Now, another one, very common, used for beams and a lot of columns, is the tubing. Often referred to as steel tubing or ST. They will actually, well, let me back up for a second. First thing, steel tube can be square, a square tube, and it can also be rectangular, both of which can be used for a variety of different constructions. A lot of times they're used for columns, not so much as beams because W-beams work better as beams, but they can be used for a lot of architectural type of shapes. You can actually take these things and roll them into a curve fairly effectively. So the key things about them is the width dimension, the length dimension, and of course the thickness dimension of the wall. That's what the crucial component of it is. Steel tubing comes in a variety of strength values. They've got what they call high strength steel, which is probably the majority of what you'll see when you get into the high strength, higher KSI value. Now, square tubing, a typical call out would look like this. You're going to see, you know, width, depth, and wall thickness. Not a big deal. But you don't see this little symbol used nearly as much as you see this used. You can either see TS 4x4 by 5/16 for tube steel, or you can see 4x4 by 5/16 TS. So you don't see the square block used that much. You do see the TS used a lot more commonly in a lot of fabrication because it stands for tube steel. Rectangular version, no big difference. It's, let's say this is a 3x5 with a 3/8 wall. It would simply be a, here we go, 5x3 by 3/8 tube steel. So the tube is the key thing, the terminology for tube. It doesn't actually have, tube doesn't necessarily mean it's square or rectangular, it just means it's a tube shape. Okay. Now, a little side note that I've run into recently on construction projects, and some of the guys on the fabrication side helped me out a lot learn about this, is one of the things that designers don't understand sometimes is the welding, the way that we actually weld. Like, for example, let's say that we are looking down a steel tube column right here, there's its wall, and we're going to weld a incoming piece of steel to it. So you might think, okay, well, how about this? We'll get a 5x5 steel tube. That doesn't look like, let's call it a 5x4 since it's more rectangular. And we'll also weld it to a 5x4 steel tube. So that way my 4, the distance from here to here, looks great. You know, that sounds good, right? Get the same part, plenty of material to work with, the edges are going to line up, and that's great. But what we find out in fabrication is, and you'll see this when you're looking close, is these tubes actually aren't square, they're rounded off. So where, and I'm having a hard time drawing this, but where you might think it's squared off, it's actually rounded. There's a fillet per all these tubes. And what happens is you have one tube coming in, that's the exact same size, and look what you have right here and here. You have a gap. And what ends up happening as they try to weld, they end up just burning away this component trying to make the jump. So, and this is just a fabrication tip. If you're looking at a set of plans that brings in the same size tube into, perpendicularly into another piece, and you're going to do like a fillet weld all the way around, be aware that it is actually better, especially if you end up doing a little sketching or doodling to make some recommendations. Be aware it is better to size one bigger than the other one. So for example, let's say that we do a 5x5 against a 5x4, so that we have that 1/2 inch there and there to work with. Much better result. I learned that, I learned that from some of my guys a little bit in specification not too long ago that worked well on a project. It just helps them out. And whenever on the design side we can help out folks fabricate better, that's what we're after. And like I said, when you're reviewing a set of plans and they have things like that on there, it never hurts to make some suggestions and kind of point that out. All right, so tube steel, not a big deal, easy to find, easy to use. Note that the wall thickness is shown, not the actual weight per foot of the tube steel. Okay. Now just to reiterate why tube steel is not used nearly as much in beams is because if we take a piece of tube steel and again we span it across some kind of open space and we push down, again our stress is up here and down here in the top and bottom parts of the piece. So let's say that we do like a section view and we look at it this way. Here is our tube steel cross section, right? Totally makes sense. And we're getting stressed not a lot up here, and we're getting a lot of stress down here. But we're not really getting stressed in these zones as we've talked about in the past. So that's why W beams actually, or even C channels, work out better, because we may only need like technically one wall to work with, so we could technically get rid of the other one and be fine structurally sound, or structurally speaking. That's why C channels or W beams will typically be used more in a beam scenario. Now that's not the same as a column. So for example, when you have a steel column and you have something pushing down on it and maybe some seismic or wind activity pushing from the side, so there's a load pushing down this way and there's a load pushing on this way, that creates stress in all kinds of different operations. So typically we end up wanting to using these extra walls more so, especially when the direction of wind may come from this way or may come from this way. Having symmetrical parts often work out well for us. It's not to say that we don't use W beams for columns too, but steel tubes can be used very effectively for columns as well. All right, so that's a good stopping point. We'll see you next time.